Hello, let's continue with our lectures. In this one, in this topic, we are going to solve um, the derivative of this function. This is the function, the 7x squared minus 5x plus 9. This is a polynomial function, and we are going to calculate the derivative for this using the method that I described in our last lecture. So let's do those 4 steps. The first one is to define the x plus delta, the y plus delta y function, which is equal to f of x plus delta x. In this case, as you know, we are going to substitute the x by the x plus delta x. In this case, we are going to power up this to the square, and then minus 5 times x plus delta x plus 9. This will remain the same because this is independent factor or independent term. Then second step is to define delta y. And delta y is this expression over here, this guy, minus the original function. So this is 7 times x plus delta x squared minus 5 times x plus delta x plus 9, and all these minus 7x squared minus 5x plus 9. Please be aware that here we have a squared binomial, so we need to expand this first. So the binomial power up to the square is x squared plus 2 times the first one by the second one, 2 times x times delta x plus the second one squared. So this is 7 x squared plus 2 times x times delta x plus delta x squared. So this is the expansion of this. I included this separately so you can see where all these numbers on or expressions comes from. That's the reason why I expanded this separately, so you can see where these numbers or variables come from. Then if we multiply 7 times x, in this case 7x squared, because we are going to multiply this by 7, so this is equal to 7x squared plus 7 times 2x delta x. This is 14x delta x. And 7 times x delta x squared is 7 times delta x squared. And if we multiply minus 5 times x, this is 5x. Minus times plus, this is minus 5 delta x is 5 delta x. And this independent term will remain the same. Then this is minus 7x squared, which is this one over here, and destroying or breaking up the parentheses, this is minus 7x squared, and minus by minus is plus, so this becomes positive, plus 5x, and this becomes negative and minus 9. So if we simplify this, we came up with 7x squared plus 14x delta x plus 7 delta x squared minus 5x minus 5 times delta x plus 9 minus 7x squared plus 5x minus 9. Okay, this appears to be a very long expression, but it's fairly simple to simplify. And in our third step, we need to have this defined, or delta y, which is all this guy over here, and divide that by delta x, which is over here, delta x. So simplifying, we have this For example, this 7x squared, this is a positive one, and we have this 7x squared negative one, so these terms are going to cancel each other. We have this minus 5x, and this is plus 5x, so the 5x will go canceled. We have this plus 9 and this minus 9, so these two terms are going to cancel. And so doing all the simplification, we end up with 14x delta x plus 7 delta x squared minus 5 delta x all over delta x. Dividing this delta x, we cancel with this one. We have here delta x squared, which is delta x times delta x. So we will end up with only one of this. So we can cancel this with one of this, and we can cancel this delta x with this delta x over here, and we can get rid of all these terms. And we will end up with 14x plus 70x minus 5. This is our last expression simplified. Then our fourth step is to calculate the limit of that function. So the limit of dy over dx is when delta x tends to 0. In this case, the only term with delta x surviving from this operations is this one, the 7 times delta x. So if delta x approaches 0, then this will become 0. 7 times 0 is 0. So we can eliminate this term. And this result happens to be 14x minus 5. And in this case, and this is the derivative of the function. So now, with this additional example, I'm confident that you now have a clear understanding of how to solve a derivative using the formal definition. Please let me know if you have any questions or comments. I'm aware of your comments or questions. Please let me know via Classroom, or you can send me a text message or an email, and I will be aware of your questions to support you. Thank you.